guys, today we will be doing we are starting on this thing called calculations. Now look at the syllabus here. We have finished 1.1 to 1.4. Today we are looking at the reacting masses of volumes and solution gases. But before that, there's an important part here. It says write and construct. Oh, okay, there's no pen. Sorry about this. Okay. Write and construct balance equations. Now here it says balance equations, but the equations here means concerning chemical reactions, okay? Chemical reactions. Now, normally for chemical reactions, a lot of them are redox, okay? Which means they are oxidation and what? And reduction. Okay, so in this case here, if there are these corrections here, it will involve electron transfer. Okay, so in electron transfer, you are interested in what? Oxidation states. Oxidation states, or sometimes we call it oxidation number. Why is not coming out? Okay, or oxidation number. Well, in Form 5, you call it valency. Okay, whatever you call it, doesn't matter. You need to know this. So before we go into construct balance equations here, we need to look at this oxidation states. Okay, now I've got another PDF, not PDF here, is, okay, right? So now here I put down here, this is on my Google Doc. Okay, I did that again. So the first, now there are three things we need to do. I hope we can cover these three things here. And I want to do it with plenty of examples, okay? First, of course, is to know what is the meaning, well, what are oxygen states or oxygen number, right? Then we look at, well, what reactions are redox reactions? How do you know them? And also, what are oxidizing agents and reducing agents? And lastly, we need to look at part of balance and write redox reactions, equations, and normal equations. Okay, these are all passive questions, right? So it will cover just this part, okay, on the very, well, just this part a lot. No, I mean, of course, if you know, it's no problem, but I assume that you don't know. So I'm going to cover most of it here. Now, the first, of course, is to remember redox reaction talks about transfer of electrons. Now, here we have, I got I know it's from Singapore. This guy is really good. I mean, he just did this whole thing. So I just copied it. Okay, now remember oxidation states involve, of course, it involve two kinds of substances. One, of course, is ionic substance, ionic compounds. Okay, and of course, then there is two, I put down two here, covalent compounds. Okay. Now for ionic compounds, it's quite simple. Right? Ionic compounds are formed by electron transfer. Metals and non-metals, yeah. So if I'm metals and non-metals react, okay, non-metals. So normally, like here will be group 1, group 2, group 3, and so forth. And of course, your TM. Okay, here will be group 4 sometimes, maybe it's group 5 lah. Group 6, group 7, okay? So when they combine, this will lose electrons, right? This will gain electrons. This will gain electrons. This lose electrons. So in this case, it's ionic. The ionic compounds are formed where one will be positive, M, right? Positive 1, 2, or 3, okay? Right on top here, M. But normally put plus first. 2 plus, okay, right? I will show you the idea of plus 2 or 2 plus afterwards, okay? And plus 3 plus, sorry. And here, of course, this one will group 1, group 2, group 3. And this, of course, will be like group 5 here is nitrogen, okay? It's 3 minus. And group 6 is O is 2 minus. And group 7 is Cl minus. Okay, now, so, of course, now the charge here, like for example, I think better go down, okay? Like you have sodium chloride, NaCl. You know it's ionic, so it's positive here, negative here. So this will become your what? your oxidation states. Very simple, isn't it? For ionic. Okay, of course, you will learn later. We go into this more, like magnesium nitride, Mg, and okay, this is +2, this is -3. So the formula is why is Mg32. Okay, so now this will become your oxidation states for nitrogen and magnesium is on here. Okay, so we look at these things some more later when we do our bonding. But now you need to remember some of these things. Okay, so for ionic substance, no problem. But for covalent substance here, right? And you say here, read here. Okay, so where is it? Okay, if it's actually nothing is completely ionic and nothing is completely covalent, because it all depends on what electronegativity is in. So like here it says, in case of ionic compounds, okay, the oxidation number, okay, will be the charge it carries. Right now, like here sodium is 1+, quite simple. Elements, if it's elements, is what? Is 0, isn't it? Like Cl2 is 0 here. Okay, so that is clear. All right, but of course, then you come to the point of when a substance is covalent. Okay, covalent. So if it's covalent, like here, all right, covalent here, you would depend on who is more electronegative, right? So the oxidation number, okay, right here will depend on the, as I said, the electronegativity. For example, okay, covalent what? For example, is water here, H2O. Okay, now you know the O, right? This is your cross and dots diagram lah. Okay. Okay. Now you know the oxygen is more electronegative now. Okay, now the idea of electronegative. Okay, see here. Electronegativity is the ability. Electronegativity is the ability to attract electrons. Now there is a chart here. I think I got it down here. I don't know if it got transferred or not. I think it should be here. Here. Okay. Right now, this is I want to show off the chlorine and nitrogen later. Now here is here. Okay. Oxygen. Right. Now this is oxygen. Okay. 3.44. Hydrogen is okay. Right. Healthy, whatever is okay. Different. Degraded. 2.2, 3. That means oxygen is more electronegative than the hydrogen, which means to say, right? That means O here. I just draw again now. Okay, since it's over here. Okay. Now that means this is more electronegative, right? It's 3.44. This is 2.20, 2.20. It acts as if this oxygen has taken away the electron from hydrogen, while keeping all the other 6. That means it's like hydrogen has lost electrons, so it's 1 positive, 1 positive. Oxygen has gained 2, so it's -2. So normally for oxides or for like water or whatever, like ethanol. Okay. Okay. Right. Oxygen is more electronegative than carbon also. So it takes 1 from carbon, 1 from hydrogen, that's why it's -2. Okay, so we take oxygen is -2 all the time, except when the only filler that oxygen is less electronegative is F. Fon, remember Fon. Okay, you learn this later lah. Okay, for now you just remember that fluorine is the most electronegative. So there's a question is F2O. Okay, there's a question later, which means that oxygen here, right? So 1, 2, 3, 4, 5, 6, and there's fluorine here. Cross, 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 cross. I don't know why that's going wrong. I think I don't care. Okay, cross F here. Cross, 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 cross. That means F will own this electron. So it's -1. Fluorine is always minus because it's the most electronegative substance in the periodic table. So oxygen here is +2, no? Okay. The only time the oxygen is plus, right, is when it's bonded to fluorine. Okay. Now for peroxides, just show you for peroxide. hydrogen peroxide. The other one is peroxides, okay? Now, hydrogen peroxide is H2. I can't get the filler down here. Okay, let's move here. Peroxide is H2O2. So it's oxygen dot 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 and cross here. Oxygen, I put a dot here, okay? And cross here for hydrogen. Right now. So here's cross with 6 here. Dot, cross, okay? For hydrogen here. Now for oxygen, because these two are same, so you don't count it, right? So here is +1, because oxygen is more electronegative, isn't it? Hydrogen. So it's here -1. Okay? So here again is +1, and so it's -1. So for peroxide, oxygen is -1, oxygen state. Okay? Okay? So remember that. Now let's go back to here. So you need to learn, you need to know the electronegativities of the substance in the covalent bond between each other. Okay, now this will help you to understand more. Okay, this very good short excerpt I got here. I'll give you a few rules here, all the rules here. I just want to go quickly, okay, and then we look at the past questions. I don't want to waste much time here. So you can go over it, okay? So the first one, of course, is oxygen number of atoms of a combined element is 0. Clear enough? So if it's chlorine 2 is 0 here. If oxygen 2 is 0 here. Where is sodium is 0 here. So any element, the thing is uncombined element is 0. Monatomic charge, right? Ion are the charge on ion. Simple as like for them Na plus. Okay, so this would be the oxygen state. Quite simple. Fluorine also is -1 now. I say fluorine here. Okay, so it's never positive. And it's only 0 if it's F2. Okay, only 0 here. Right? So and all the now actually you have got interhalogenic compounds like for example FCl. Not okay, FCl. Okay, so this is -1, this is +1, no. Okay, you have got FBr. Okay, this -1, this +1, no. Okay, so you must understand the electronegativities. All right, oxygen, right, is always -2, except for what? To fluorine is positive 1. Okay. And of course, if it's -1, is for the peroxides. See, peroxides here. So you need to go over this yourself, right? A metal is always positive, right? Because it's basically an electron donor. Okay. Now, for example, hydrogen. For hydrogen, right? It can exist as H2, which is 0, right? Iron H positive. +1. Now, if it combines, hydrogen combined with non-metal, okay, H plus non-metal, right? You give you H. Now this is covalent, remember, this gas is it's a gas. So this is -1. Okay, I don't know why it's not doing it. Okay, come on. Okay, let's do again. It's -1. I don't know why, man. Okay, let's go over again. Sometimes it's electronic stuff. I don't know why. It's -1. Pen. Review. Thinking. Pen. Okay, thickness. Okay, this is -1. I do one yellow, one red. Okay, this is -1, this +1. Okay, now. So hydrogen is always +1 when you compare to non-metals, okay? Now, but if you form metals, okay, plus hydrogen, you have this, no? Like your hydrides. I don't know whether this form 5 work, okay? By the way, hydrides. Okay, sodium hydride is NaH. Ionic is +1, this is -1. Magnesium nitride, hydride, MgH2. This +2, this -1. See, so -1 for with metals. Okay, aluminum hydride, you have seen it before, I think. In your form 5, Yep, I hope so. Positive 3, minus 1. See now. So hydrogen is minus 1 when it's minus 1 when combined with a metal. Okay, metal. See metal. Okay. Non-metal, of course, is plus 1. Okay. Now the sum of the oxygen states is equal to the charge. For example, here. Okay. Right here. This is all form 5. Form 4, form 5. I just want to go a bit only. For example, let's say for example potassium dichromate. Okay, I just give an example. Okay. Okay. Now this is potassium dichromate. The whole thing is a salt, right? The whole thing is a salt. The whole thing here, if it's a salt, the overall charge is 0. The summation, see, this is what is called a summation of all the oxidation states will be equal to the charge here. So I get, now let's say, okay, potassium, this I want to find out about chromium. What is the oxidation state for chromium? Okay, let's put X here. Okay, right? Oxygen is always minus 2, so I must memorize some of this. Potassium group 1 is plus 1. Okay, so here I will have 3 things, the summation. 2 times plus 1 is 2 times plus 1 plus 2 times X plus 7 times minus 2 should be equal to 0 charge. So the summation. So it's plus 2 plus 2x plus, minus 14 give you 0. So here's 2x minus, 12 equals to 0. Therefore, x equals to positive what? Positive 6. Now here you always put positive first. There you always put the number first. Okay, so I'm sorry. So it will be 2 plus negative again. Okay, right? So positive 6. So chromium is plus 6. Okay, so if they give that, like here MnO4 minus, which means the overall charge is minus 1. Let's say Mn is manganese. I don't know what is this. Let's say I put A here. Okay, so A times 1. Okay, plus, okay, plus oxygen is minus 2, 4 and minus 2. So it's A minus 8 equals to minus 1. So you've got A equals to plus 7. Okay, I won't go on. Okay, now this is as much as we go. Later, this one, I finish it lah. Okay, now sometimes for the same substance, now the carbon is a bit different. For the same substance here, okay, right? The carbon here can have different oxygen states. Now the idea is, right? The whole thing here, carbon and carbon here is same, is it? Carbon and carbon here is same. So now this whole thing here is equal to 0. So hydrogen is plus 1 because carbon is more electronegative. Right now, here is plus 1. This plus 1. So oxygen is minus 2. Oxygen is the most electronegative. So what is carbon? Carbon will be the remainder. So it's 3 positive here. So it's plus 3. Okay. Then plus oxygen is minus 2. Let's say for your carbon, let's say it's X, is equal to 0. So what is it? It is, well, here is plus 1, okay, right? Plus X equals to 0. So X equals to what? Minus 1. That's why, see, it's minus 1 here, okay? So this one here, let's look at this one here, okay? Right? So now, carbon here, which means 0 here. I mean, the same electronegativity. So it's plus 1, plus 1, plus 1. So it's become minus 3. So minus 3. Okay. Now, if you work it out here be 0. So for every carbon atom in the molecule, there are different valencies or different oxygen states. But then they have this thing called average. So here is a summary. Okay, right? You here, where I can say here. See here. Okay. Plus 1, plus 0. See now. Minus 3 divided by 3 atoms is equals to minus 4 over 3. So the overall valency of carbon in this molecule is what? right? It's equal to minus 403. Now that's how you calculate for carbon in organic compounds. Understand? Okay. All right. Now a couple of more things, and we'll go on to the skill. I call it a skill. I can go over all these examples here. I won't go over with you. The skill of determining oxygen states, redox reactions, and so forth. Now, first of all, you need to know what is redox reaction. Now, auric, famous auric, auric here. Auric oil is oxidation is what? Loss of electrons. Okay, is reduction is gain of electrons, RGR. This is form 4, form 5, blah. So when X undergo oxidation, it will lose electrons, right? So X will lose electrons. So it's oxidized to Y. Okay, so X, because it's a reducing agent, now reducing agent. Okay, how do you know it's a reducing agent? Very simple. This is the acronym they use. Okay, reducing agent. Okay, reducing agent. E for electron donor. Electron is donor. Okay, so the other don't have. Okay, so group 7 is group 7, of course, is basically a reducing agent. Of course, this one here, normally metals. All metals, because they donate electrons. Group 1, group 2, group 3, okay, and even your TM. Okay, they are all electron donors, so they are all good, very good oxidizing agent. So reducing agents. Yeah. So they're all reducing agents. See, even I get mixed up. Reducing. Yeah. See, I don't know what happened. Okay. Never mind. So we go to the other one now. I think this is very lousy. I won't use this anymore. Okay, we use the other one here. Okay, better. Okay, reducing agents. So now, yeah, I cannot. I need to go back there. I don't know why. Okay, never mind. So only this one is a problem. So can't trust these things. Okay, never mind. Now let's shift back to the other slide here. Right. Now you know that. Maybe I write here. Okay. Okay, right here. All right. So remember, auric oxidation is what? Is auric oil. See, because I click the button, see? Oxygen is loss. Okay? is reduction is gain. Electrons. So this fellow here, this fellow is group 1 metals. Okay, metals. So they lose electrons. Group 1, group 2, and group 3, and your transition metals. Okay, this is normally your non-metals. Okay, right? And their group 4 normally is very hard. It's in between. Group 5, group 6. Now they call it group 15, group 16, and group 17. Okay, now mind whatever. This of course like your nitrogen. Okay, so nitrogen become nitrogen. This is oxygen, and this is your halogens, okay, chlorine, and so forth. These are all electron receivers. Why? Because they, like group 7, they gain 1 more electrons to become stable. Again 2, again 3. So all these are electron receivers gaining electrons to become what? Stable octet. Okay, so they follow the rule of stability. These are lose electrons, what? To achieve what? Same thing. Achieve what? Stable octet. Okay. C, D, D. Okay. So if you talk about agents, okay, so metals are mainly reducing agents, okay, which become oxidized. So electron donors. Group 7 on non-metals are basically oxidizing agents. They will receive electrons, oxidizing agents. Okay, they are electron acceptors, they call them. Okay, the outside not working, so I don't care. So it's electron donors. Okay, now these are the few things you need to know. Now quickly, I finished half an hour already just on this. Now I'm going to go through all these questions here. All right. Hopefully we'll take about 20 minutes, and then the other 20 minutes we will do other questions. Okay, now the first one. Okay, 226. Sorry, yeah, 222 lah. Remind me of the road. All right. Okay. Now here. The question 6. Ammonium nitrate can decompose explosively when heated. Recently you see in Lebanon, the whole place got exploded because of this stuff. Okay, because this fellow here, right? When you hit, let me put this on first. This fellow here, right? When you hit, it will decompose to give you N2 and oxygen, right? Which will support combustion, and it will just blow up the whole thing whenever there's something combustible after. Okay, so this is your N2O. Never mind. I better rub it off first. Disturb me. Okay, let's go back to here. Remember, I use this in my farm, so as a source of nitrogen onto the soil for my durian trees. Okay, what changes in oxygen numbers? The correct oxygen numbers. Something called oxygen states of the 2 nitrogen atoms in here when the reaction proceeds. So now, how to work it out? Very simple. So they say, which means NH, okay, 4 NO3. These questions are very good one, so you better make sure. Hydrogen, of course, is +1. Okay, because FON, N is the most, F is the most saturated, then O is not, right? So now this is -2. You can work in 2 ways. The overall, normally work like this. This fellow here, this one here. Sorry about this. Okay, better now. Okay, yeah, here. All right, this whole thing here, nitrate is -1. Easier to do away. Your ammonium is +1, okay, because there are 2 separate ions. Remember, PAS salts, potassium, ammonium, sodium salts are all ionic. Okay, so hydrogen is +1 here. So hydrogen is plus here. So it's +4 the total here, right? Okay, to be +1 here, nitrogen must be -3, isn't it? Yes, not. Now for nitrate, sorry, the whole thing is -1. So oxygen is -2 here. So here will be -6, right? So here must be +5, isn't it? To get you minus here, see now, okay? So it's -3 and +5, the 2 thing here. Right now, okay? When this reaction proceeds, what are the changes? Now, look here. Now it will become N2O plus 2H2O. The whole thing here is a molecule, so it's charged 0 here. Oxygen is -2, so to be 0 here must be +1, isn't it? Right now, okay? Because 2 times +1 is +2. -2 times 1 here is +-2, give you 0. You know. So from 3 to +2, right? So what are the changes in the oxygen numbers, right? +3, -3 to +2, how much? They change 5, isn't it? Sorry, how much? 3. What am I doing? Sorry, here's 1 now. 1. See, I even made a mistake. Okay, +2 is the one. So go to +1. Okay, now. So +1. So 3 + 1 is 4, isn't it? So a change of +4. Okay, +2 here means times +1 here. Okay, okay. I just say something wrong. All the things is not like being upset me. Okay, now here's +5. Go to same thing here, +1. So how much did it change +5 to +1? It must accept how many electrons? 4, isn't it? Change of -4. -4. So this is the answer. Okay? If you cannot get the first time, you go over it again on your free time, okay? The video and tape again and again. Okay, Page 233. I'm going to a lot, so you can see 233, number 19. Okay, now here. Which compound contains two different elements with identical oxygen states? Normally I get a lot, normally the first one now, okay? Okay, now here. I just work on the first one, you can see HCl, okay? So, for example, oxygen here is the most electronegative, so it's -2. Remember, the whole thing is charge 0, right? -2, okay? Right? Or hydrogen, if we don't know, chlorine is always +1. So what is chlorine here? So X here. Remember, it's all 1, 1, 1, okay? Right? So it's +1 times 1 plus 1 times X plus 1 times -2 give you 0. Right? So it's +1 plus 1 plus X minus 2 give you 0. Right? So it's X minus 1 give you 0. So so X was X for chlorine is +1. See now? So X is plus here, chlorine is +1, okay? Hydrogen is +1. Obviously, which compound contains two different elements, which hydrogen and what? And chlorine here, having the same identical. So obviously, you can work out the rest yourself, okay now? Okay? All right? So, example here. Another one, 2, 3, 4. Okay? 2, 3, 4. See, a bit harder now. Oxide of titanium, TiO2, used as a whitener in toothpaste. Also used in a paint, titanium oxide. It's a very white substance. It's obtained from the ore iron 2. Now, they put iron 2 here for a reason. It means iron got 2 or 3, isn't it? Oxidation, isn't it? Right? 2. So, titanic, this one here. All right? Okay, what is a change, if any, in the oxygen state? So they're very kind to tell you these are the two expressions they use for oxidation number, oxidation state of titanium direction from that to that. Okay, so now you got to work it out. You want to work it out. Some of you are very smart with maths, so no need lah. Okay, remember the whole thing here is compound, so it's charged 0, isn't it? Okay, 0. So remember this +2. Why +2? They tell you here is iron 2, right? Oxygen is always -3. Sorry, -2. What am I doing? I tell you the word document being upset. Okay, let's say it's X here. Okay, now there's 1 here and 1 here. So there are 3 substances, so summation of these 3 fellows here. So this is +1 times +2, 1 times X, 3 times -2, give you 0. So it's +2 plus X minus 6 give you 0. So it's X minus 4 give you 0. So what is X? +4. That's all. Yep. Okay. So now for titanium oxide, TiO2. The whole thing is 0 here. Let's say put a Y on top here. This is -2, isn't it? Because FON, oxygen is very electronegative. So this is, of course, the 2 things here. This is 0, not 60. Okay, so 2 times -2 and Y times 1. Okay, so it's Y minus 4 give you 0. So what is Y? +4. Same. That's why it says here no change. Okay, so the only thing is always have to change. What change is something else. Okay, now. All right. Okay. So this kind of things here, iron becomes something else, so we don't care because they don't give us what is the other substance about. Okay, don't try to figure out what you're not supposed to figure out. Okay, 2, 3, 5. Another one here. This one is a bit longer. Okay. In the treatment of domestic water supplies, chlorine is added to water to form HO. This hypochlorous. Okay, hypochlorate. Okay, now this is actually a bleach. Okay, HCO. Chlorine you learn later in your group 7. A lot of oxygen still now. +1, +2, +7 also got. -2, -1. Okay, plenty. So don't just be a form 5. Chlorine always -1 and 0. Not necessarily. Okay, so you work it out, all these things here. Okay, so now there are 2 reactions here when you put chlorine in water. The first reaction is one here. They will form HCl and your HClO. This is a bleaching solution. Okay, And this one here further react with water to give you this one here. Okay, so finally this become acid. That's why this acid here will kill up the germs in your water, and also this one here. Okay, actually this one will break up to give you O, Cl plus O, no? Right? And the nascent oxygen here will kill bacteria also. So that's why it's very effective in bacterial killing. Okay, you know bacteria, isn't it? What is the overall change in oxidation number of chlorine? Okay, when forming this ion from aqueous, that means from here, now here is charge 0, remember. Why elements here? And what is this here? Very simple. Now the whole thing here, ClO minus, the whole thing here is -1. Yeah, oxygen is more electronegative, so it's always -2. Okay, right? So let's say this X here. So 1 and 1 here. So two entities here. So 1 times X and 1 times 2. Okay, so X plus 2 give you -1. Sorry, -2 here. I say you don't make a mistake. Sorry. Mr. Lai is idiotic. Okay. So sometimes signs are very important. Even I make mistake. Okay, so just be careful. Okay. So here is -2. So X equals to what? -1 plus 2. X equals to +1. So the chlorine here is +1. This -2. Okay, and CH here. Okay. So it's changed from, what is the overall change? From 0 to +1, isn't it? So this is the one. Okay. All right. Another one. Okay. 237. Quickly down here. Okay. 237. No, not 237. Yeah. Okay. The level, in which substance the nitrogen exhibit the highest oxidation state? Can work it out or not? Okay. Okay, I just work out for you. Of course, it's this one here. Okay, here. It's very simple. This -2. This whole thing is 0. This what? +1, is it? Okay. This is -2. This is what? +2. Sometimes some calculations are quite simple. This is -2, so it's 8 here. 2 here is +4. No. Okay. Now here's a bit. You got to change it to Na+ first. Better. And then nitrite -1. Okay. So now this is -2, -4, is it not? So it's +3, isn't it? That's not right to be done here. So which is the highest? Of course, C. Again, very easy then. Okay, 247, another one. Okay, then we go to a bit harder ones. Okay, 247. Where is it? Okay, here. It's 247, yeah. Okay, all right, you can see now chlorine is very common one. This one is it's a very common equation you find in your group 7 later when you do your inorganic chemistry. Solutions containing chlorate are used as a household bleach and disinfectants. This solution decomposes on heating, give you blah blah blah. Okay, which oxidation state is shown by chlorine in each of these states? Very simple, isn't it? Right? Now, of course, the whole thing here, see, is ClO minus. That means the whole thing here is -1. So oxygen is -2. To get -1 here is +1 now, of course, you know. Yeah. So ClO3 minus, which means the whole thing is -1. Okay. So it's -2 here. So it's -6 there. -6. How can I get a -1 here? Must say +5. It's not. Okay. Of course, the last one is -1. So -1. These two -1. All right. Simple. CO3 +5, +5, and +1. Okay. All right. Now let's look at something different. Okay. 252. I'm going a bit faster. Now these are skills. You need to know how. Okay, how to do it. Oh, you're 253. Oh, 252. I'm quite stupid today. 252. Okay, here we are. In the redox reaction shown how the oxygen states of vanadium and sulfur. Okay, simple, isn't it? Okay, remember it's all the same. Okay, so I'm going to do a bit more, then we're going to shift gear. Okay, Okay, today if we finish early, that means good luck. Remember this VO2, remember the plus, that means the whole thing is positive. Not for oxygen, remember, okay, learn to view things. This of course -2, right? So 2 times -2 is -4, isn't it? This work out fast, okay? So what must this be to be plus here? So it must be +5, isn't it? Okay? See now. So when it is +5, okay, so change to +3, +5 to +3. So these two are possible. So sulfur dioxide, the whole thing is charged 0. So oxygen is -2. So of course it's what? It's -4. So it's +4 for sulfur, isn't it? Okay? Right? Now sulfate, the whole thing, remember sulfate, guys, the whole thing is 2-. Okay? So on top there, you put a number first, okay now? Right? But for oxygen it's the plus first now. So see, you see how they write it? Oxygen state is +5, right now. For up here, you put 5, 2, and minus. Okay, the charge is a bit, the numbers, the correct is a bit different. But it's -2 oxygen, so it's -8 here. Okay, so to be -2 here, of course, it's a +6 there. Yes, so it's +4, right? To +6. Okay, +4 to +6. Obviously, this one. Right. Sorry, +4. Sorry. Oops. Yeah. Sorry. Okay, these two are correct. Boleh ya? Okay. Now let's look at a few more. Okay. Let's talk about reduce and oxidize it. 254. Down 2 steps. All right. Now this is about oxidize and reduce. See, they ask you different things. Okay. A space shuttle's upward thrust came from the following reaction of aluminum and ammonium perchlorate. Okay, it's perchlorate, right? So forth, which statements of this are correct? Now remember, all right, aluminum is element here, so it's charged 0. Now perchlorate, you can work it out. Ammonium is NH4 is 1 positive. Separate them, okay? And of course, it's ionic, so ClO4 it will have to be -1, isn't it? Okay, right? So of course, then you work it out for chlorine. Now this is oxygen is -2. Yep, -8. To get -1 here must be 8, must be +7, is it? Chlorine, because it's 1 here. 1 here. Okay. Okay. So right now they ask for aluminum, chlorine, and nitrogen. So what for nitrogen here? So we work out for this one here. We go for aluminum, okay, +7 now. Now remember, hydrogen is +1. So +4. To be +1 here must be -3, isn't it? Okay, so it's -3. So now here, of course, in here, Al2O3, of course, is -2. This is +3. Aluminum. This is also +3, isn't it? This is -1 here. Chlorine, so it's +3. So aluminum is +3 for both of them. Okay, all right. Okay, don't have this one here. This is 0 here. Okay. Okay, so aluminum 0 to +3 is what? Oxidized. Why? Electrons are lost in, so it becomes more positive. Now, a very good thing I learned last time when teaching SPM is if this oxidation state, okay, oxidation states. Okay. And this 0 here is +1 here, +2 here, and +3 here. You go higher, -1 here, -2, and -3 here, right? So if you lose electrons, so up here is lose electrons, loss electrons. Okay, right? Go down here is gain. Yeah. Okay. So going up here, loss is oxidation. Going down here is reduction. It's not. So you can see from the, so is if it got becoming less positive, down here is, right now, down here is less positive or more negative, that means it's reduction. It become more positive, up here is oxidation. So become more positive, so it's correct. Chlorine is reduced. So from chlorine here, which is +7, right, to 1 here, +7 to 1 here, +7 to 1 and going down, okay, right? It's +7, means again electrons are +7 to Cl -1. So it's reduction, reduced. Nitrogen is oxidized. Nitrogen here is what? -3. Here is 0. -3 to 0, that means it must have lost electrons or lost electrons. Lost electrons. Okay? Lost 3 electrons. That means it's oxidized, isn't it? That's not. Yeah? Nitrogen is oxidized. That's not. 1, 2, 3. Alright? Okay, so they come in different forms. I think I want to one more, then we stop. Okay, let's look at something here. All right, I think we stop. Okay, you can read for yourself. Now, next one, of course. Okay, got 15 more minutes. I need to do 2 more things. Okay, I plan here 2 more things. Okay, next one, of course, is redox reactions, okay, redox equations, all right. It's a bit different, but it's using the same idea. Okay, page 322. A lot of coverage today, okay, so if you're not very good in maths, but this is very simple maths, it's no big deal, okay. Now here is this about equations, all right, same idea. Now you can see that now the first one here, 2, I didn't do this. Okay, you can see there are many examples here. I will give you as a homework later. I'm going to give it up later in some form. Okay, Google Classroom or whatever lah. Okay, right? You can try others if you want to. Now here, remember in redox reaction, there's always 2 half equations. Okay, one is for oxidation, one is for reduction. Half equations, there are 2. Okay, one is for oxidation. Okay, which means it will lose electrons. Lose. Okay, the other one is reduction. It talks about gaining electrons. You need to write 2. And then these 2 add up, you get what? Your overall equation, which you use. Okay, so these are 2 are called half. They're called half ionic equation. Okay, normally they call it half ionic equation. This is the overall equation. Okay, okay. Now here they give it to you. See, the following half equation occurs in potassium iodate. You will learn a bit more later when you do your practical. KiO3. Okay, KiO3, of course, K is positive, IO3 is iodate. You also learn this. The whole thing here is 1 negative. When you do your group 7, never mind. Okay, now they give you the whole equation here. Don't worry. Okay, this one. 2 Cl minus, and it looks very chunky, very bombastic, but it's plus electrons. Okay, to give it here. All right. Now we can actually work it through. Okay, let me work it through. Okay, now here, what is this? What is the oxidation state for iodine here? Now this -2, so of course it's +5, isn't it? Okay, right. Now you give it this one here. ICl2. God, sorry. This -1. Now this -1 here, it's not. So what is I here? 2 minus it, so it was a +1, is it? +1. Okay, so +5 to +1 here, it means every iodine here must accept how many electrons? Must accept 4 electrons. Yeah? See now. 4 electron means the 4 negative, +5 to +1, right? That's why +4 electrons, +1. Okay? The other fellows all no change. Chlorine no change, oxygen no change, hydrogen no change. It's the iodine that changes. Wrong? What? +5. You work it out slowly yourself. I'm going a bit fast, I know. I won't come dilly-dally here. Okay? To +1. Now the second reaction, of course, is I2. When iodine, okay? Right? Iodine here. Okay? Now who is going to supply? Who is going to supply the electron? Who is going to give it? You can't get from here. Can't come here. It must come from something. So who's going to give electrons? See now here. It's iodine here. Okay? So iodine plus 4 Cl minus will give you this one here. Now remember iodine here is charged 0. Okay, now I We just learned that ICl2 here. Now this is positive one. This one, positive one. Right? So since there are two I here, two of them. So from here to here, it must have from zero to +1, it must have lost 1 electron. Since there are 2 iodine, it must have lost how many electrons? 2 electrons. See? Okay? So these 2 electrons came from where? From the I2. 1 I give you 1 electron. So 2 I from here will give out 2 electrons. So now this is, of course, this case here is except electrons here. So this is a reduction. Half, this is your, what? This is reduction. This is your oxidation. Okay? Now they ask you, the following half reactions occur when potassium iodate in HCl solution, blah, blah, blah. Okay? This two here. What is the ratio of IO3 here to I2 in a balanced chemical equation? That means for the overall, this is the overall equation, means here. So these two, now you add up everything here. So this one here, for 1 mole here, I'm going to give blue color, okay? Blue color. See, for 1 mole here, all right? For 1 mole here, right? It must accept, it must receive 4 moles of electrons. Who's going to give it? This fellow here. But 1 mole here give you only 2 electrons. So how to give 4 electrons? You times by 2 here, times 2 here. So times 2 here is times 2 is 8 here, times 2 is 4 here, times 2 here is 4 electrons. Okay? So you add them up here, this one cancels off. See now? See? So you can add the whole thing up. You add the whole thing up. This is the overall. Okay? So 1 will be IO3. I added for you. Okay? Plus, you can put the 2Cl minus first. Okay? Everything is same because I didn't multiply any of these things in the reduction. Okay? Plus, now some things can cancel. Sorry, you can cancel now. Here are 2, here are 4, here are 8, isn't it? Right? So when you add them up, right? You add them up. Okay, you add right? Because you add, you can cancel off. You add, you bring this up over this 2 electrons up here, it's minus now. So add on here should be 8 plus 2, so 10. Sorry about this. So it should be 10. Okay. Yeah, come on faster. Okay, it should be 10. Okay. Then hydrogen here are 6H plus here. And now how many of your I2 is 2 there? 2I2. See now, give you, okay, all the things here. So ICl2 minus is same as here. So 4 plus 1. So it's 5 now. 5 ICl2 minus, okay? Right? Plus, of course, water, 3H2O. Now, this is the overall equation. Okay? Here, overall equation. You will see later how this, you need to work out all these things to finally get something here. They will ask you, no. So what's the ratio? 1 is to, sorry, I forgot to put here, I2. 1 is to 2, is it? See? 1 is to 2. Go away, work it out again yourself and see how it works out. Can do? Okay, I don't think I have time to finish everything. Now we do 2 more. This redox balance equation, the one I think is common sense. Now okay, question 3, 8. I'm sorry for those of you whose maths are not too good. I know I got students who are hopeless in maths, they find it very hard to come balance. Just too bad that you take what else to do A levels, chemistry. And look out, that student of mine, I tell you, let's cut the story short. I took him up only in upper 6, right? So I used to chase him with a cane last time because I'm very, I mean, just play a fool. No, you cannot do ratioing. No, I tell you, oh dear, how are you going to? I took him at form 6, upper 6. I didn't teach him lower 6. And so, let me see. Yeah, I think upper 6. And so he's repeating his AS, and I need to make sure that he's able to do it. So I make him, I literally slap the fella, no? So finally he got it, right? And he got A for his chemistry. Just got 80 marks, no, I tell you. My goodness. I say, never mind. We will get there, but you must practice. Practice actually don't make perfect. It's perfect practice that makes perfect. So you make sure perfect practice perfectly okay. Now look at this one here. Now here they give the OR equation, right? Now look very carefully. Now it's a skill you need to acquire. It's a skill. A skill must be practice, and you must make it perfect the first time. Don't get practice the wrong thing 100 times, so get wrong, isn't it? You idiot, isn't it? Okay. So perfect practice. Make sure the first time you get it right. You know, do it again, until you get it right, then practice the right one. Reaction between acidified dichromate, okay, here, in case you don't know, is Cr2O7 2 minus, okay, minus 2 minus Cr, 2 minus, okay, and aqueous Fe2 plus, okay, remember, the 2 first and then the minus, okay. The reverse, of course, if you ask the oxidation state, is what? Is minus 2, okay. So the way they write this is a bit different. So please observe correctly. Aqueous Fe2 plus results in this one here. Okay. Now remember, they tell you the chromium here, of course, what now? For Cr2O7, you have to work it out, baby. 2 minus here. The whole thing is minus 2 or 2 minus cannot. So here is minus 2. It's minus 14 here, 2 here. Of course, what's chromium here? Must see. How much? Plus 6 not. Right? Because plus 6 with plus 12 plus minus 14. Yeah. See, I get mistakes here. I can get mistakes also. Because they're minus 2. Right? 2, because it's plus 12 minus 14 gives plus 12. Okay? Which is true. So it's plus 6 here. So plus 6 has gone to plus 3, isn't it? So you can see here, this is plus 6 and the plus 3. All of them are correct, see not? Okay? Right? And you know, Fe for all of them here, plus for iron plus 2 is going to plus 3, isn't it? Okay, now they ask you, okay, which is correct? Now all these are overall equations. So what? Overall equation, or the final equation. That means now you must write out the 2 equations, okay, to see which is correct. Very simple one. Now I'm going to do it a bit down here. Okay, so remember, you have the first equation, which is Cr2O7 2 minus. Okay, of course it will have the plus or your H plus. Why? Because you take out the oxygen. Okay, I'll put it here to give you. I put plus here. Okay, oxygen 7 of course must be 7H2O. Right? That means here must be 14, isn't it? Understood. You can see all 14. We need to tell you already. But now here must be Cr3 plus, isn't it? Okay, or 3 plus 3. So 3 plus. Okay. Now here, for one more here, there are 2 chromium here. This is plus 6 in it. Yep. It's not plus 6. Right? Remember, here it is plus 6. And you have to work it out, okay? Plus 6. So plus 6 to plus 3. For one chromium, plus 6 plus, to go to chromium 3 plus. It must have here gain 3 electrons in it, right? Gain. So if there are 2 chromium here, that means that this fellow here must gain how many electrons? 3, must gain 6 electrons now. So here will be 2 here. Understand? Pronto? Okay, so I'm going to put down here, rewrite this equation again. I'll write up here. I'll put in red. Okay, so at least, so we have, sorry, here. Come on. Okay, so finally we put here Cr2O7, right? Nicely, okay. 2 minus here, plus 40. This is the real one, okay? Plus 6. I know why plus 6 electrons, will give you, of course, 2 Cr3 plus 7 H2O. Of course, this will be what? Electron accepting, accept electrons, gain electrons is reduction. Okay? Now, of course, who will give you the 6 electrons? Who? Must be the Fe2 plus going to Fe3 plus. So now put down here. So Fe2 plus is going to Fe3 plus. So when it goes there, it will have to lose one electron. Now, some people put minus electron here, but I don't like it here. I put plus electron here. Okay, so now this is oxidation. 1 mole lose 1 electron. Now they need 6 electrons here. So this one must be 6 now. Okay, so how many moles of Fe2 plus must write for 6? 6 will give you 6. And okay, why put 6 in? To get out the 6 electrons here. So now here I've got 6 Fe2 plus, right, slowly, yeah. Okay, we'll go to 6 Fe3 plus how many electrons? 6 electrons. So now this is oxidation. So now the whole equation must balance everything. The electrons must balance. Now here cancel off. Like it's like 2 simultaneous equation. Now just add up. So 1 mole here of Cr2O7 2 minus, okay, plus 6 moles of Fe2 plus 14 moles of H plus. Electrons will be cancelled off. You must balance off the electrons. Electrons must be balanced off, must be same. Okay? There's no electrons in all these final equation. Yeah. To give you what? To give you arrow 2Cr3 plus 6 Fe3 plus plus 7 H2O. Now you tell me which is the correct answer. Obviously the last one is D. Is that clear? Now it's 1 hour already. Okay. Now I want to do one more. Just Mr. Rice, I always say that. Okay. Okay. 2 more actually. Now you try. Okay. Okay. 3, 7, 3, 8, 3, 8, 7. I should have one more to do, but I did already. Okay. 2, 7, 9. Oh, one more. 2, 7, 9. Okay. Oops. Oh, on top here. Gundu. Okay. All right. Well, all right. Now, this is the, I think, the hardest one. Okay. Never mind. Now this whole equation here. All right. Remember chlorate. This one you do a lot in your group 7 now. Chlorate ClO3 minus. Okay. See. Right. Are produced in a redox reaction between chlorine and hot aqueous hydroxide. This is from NaOH. Chlorine. Okay. All right. Oxidation numbers can be used to help. See now. Oxidation numbers can be used to help the balance of equation. Right. Okay. So now this is the overall equation, right? You need to work it out. The 2 half what? Ionic equations. Okay, which means you have the oxidation and the reduction equation. Okay, now let's look first. Right, chlorine here is 0. Okay, look at the chlorine. Because they only want the chlorine. V, C here, and don't care about the Z, Z, and the B. Don't care. So here is now -1. So chlorine got Cl minus, and of course here. Now here, very simple. Now the whole thing, so ClO3, the whole thing is minus, okay now. So it's -2, it's -6, isn't it? 3 times -2 is 6. This one is +5, isn't it? Yes, not. So here is +5. And here is -1. And here is 0. Now watch carefully, watch. So from 0 to -1, okay? The chlorine, 1 atom of chlorine, right? It means for Cl to go to Cl -1, it must be accepting 1 electron. Yep. Now for Cl again to go to, here to go to +5, to go to Cl +5 here. Oh, sorry, 5. 5 plus. See, I always have a problem with this also. No? Don't think that you got. Get a rub. Okay. Come on, man. Hurry up. Okay. So it is 5 plus. So here's 1 minus. Just 1 minus. Whatever. Okay. So what happened? Here it must have lost it, right? for 1 mole, for 0 to the minus 5, it means must have lost something here. Some people put minus 5 electrons. Or put here plus 5 electrons. That's not. Yeah, better lah. Okay, don't put minus here, very bad. Okay. Don't know why. Okay. Ooh, come on. You want to hurry? Okay. Okay. Where is it? Full. Okay. Right. So now for here, for Cl to go to plus 5, right now, it must lose 5 electrons. Okay. So if 1 mole lose 5 electrons, that means how many moles this fellow here must accept the electrons? 1 mole accept 1 electron. So 5 moles will accept 5 electrons. See now, to give 5 here, because the total must balance off. See now, so the total here is 5 plus 1 here is 6 Cl, such 0 will go to 5 Cl minus plus the 5 electrons will cancel off plus 1 mole of Cl5 positive. Right now that means 6 Cl 0 actually is equal to Cl2, isn't it? 3, isn't it? So it's 3 here. So V is 3. Okay. So of course here's 5 Cl minus, so it's 5 here. Okay. So Cl 5 plus here is 1, so it's 1 here. So Y is 1. Y is 1, so is Y, this 2 is 1 here. Okay. X is 5, easy busy, and V is 3. Is understood? Now, of course, this is of course reduction. Okay. This is what? Oxidation. And what is the final equation called? Redox reaction, which is this one here. To give you the whole thing. Okay, I think I saved my time a bit. Never mind. Is that clear? You have to go back and practice perfectly first. Then practice again perfectly until you get it perfect. Your mind must be set. This is all oxidation states. You have to do this. No choice. Every time they come out, there's more questions in my notes there. You can try it out later. Okay? But go through all these. I'll give you very simple ones. The first one, of course, is to find the oxygen state. Second one, to use the oxygen state to find whether it's oxidizing agent or reducing agent. Thirdly, I ask you to use this one to find the two half equations in the redox reaction. And then from there, you get your final overall equation. Okay, so we did 3 things today. All right, I just write it out here. Okay, the 3 things. Actually, it was in the other thing, but the thing went berserk. So the first one of is we find what's the oxidation state. Okay, so you gotta memorize all those things. Right now, this is my notes. Okay, the metals are all positive and so forth, ionic state and covalent. Okay, 2, right? You need to know which is a reducing agent and which is the oxidizing agent also. Okay, whatever. Okay, and of course then you use this to calculate right the oxidation states. 3, you need to derive right the 2 equations, right, the half equation, half ionic equation. Oxidizing reaction and reducing reaction. Okay, and finally to get what? The overall redox reaction equation. Okay, right? Thank you very much for seeing. Don't forget to put a like, idiots. Okay, I want to stop this. Stop.